Okay, so now let's talk about what the ChorusText device is made of. So at the core of it are the three slide potentiometers for the line, word, and character potentiometers. These are motorized slide potentiometers so that I can instruct each one of them to move at a certain position. And there's another potentiometer, but instead of linear one, it's a rotary one, which is this mode switcher guy right here. You can see the motor, it's pretty big motor. You can see the motor behind and beneath it, underneath it. Okay, and for the linear one, it's is it visible here? It's at the corner. There, I think you can see that black box. There's the motor. So yeah, so four motorized potentiometers, three sliding ones and one rotary one, and of course I need a way to control the motors, and I'm using Adafruit motor shield and an Arduino Uno, which is down here. That's the Uno and the motor shield underneath it. Oh, I left the power on. Okay, and yeah, and I've got quite a lot of push buttons, 20 push buttons. I'm not sure if you can see them here, but I'm using three shift registers underneath that cable. That jungle of cables. So I have three shift in registers. Each shift in register allowed me to control 8 push buttons. So I have three. I can control up to 24, but right now I only have 20 push buttons. So but in future I can see that the number of buttons will grow pretty soon. And then I also have two linear taper rotary potentiometers for adjusting the speech rate and spelling rate, and these are just ordinary potentiometers. They just have that fancy knobs. So the Uno has 6 analog inputs, 4 of which are taken up by the slide potentiometers and by the motorized potentiometers. Actually, 3 for the sliders and 1 for the mode switcher, and the other 2 is used up by I2C of this Adafruit motor shield. So I actually ran out of analog inputs already. Then I add a breakout, a small breakout circuit from Adafruit that allows me to hook up 4 more analog inputs. I think it's called ADC, analog digital converter breakouts, and these ADCs are 16-bit resolution, so it's much finer than the 10-bit analog inputs on board the Arduino Uno. In future, currently the ADC breakout boards, 16-bit ADC breakout boards, are connected to the to these 2 analog inputs here, the potentiometers for adjusting speech rate and spelling rates. In future, I might migrate the 3 sliders to use the ADC instead of the onboard analog input on the Arduino Uno, simply because the onboard ADC has much finer resolution, 16-bit, compared to 10 bits on the Uno. So And let me think what else. Then these three motorized potentiometers are actually they have a pin or an interface for detecting touch. So so we can detect whether the user's finger is resting on the knob or not. There's actually a small pin that can be used for that. Just connect it to the wire and then connect it to a capacitive touch breakout board, and then as the user places his hand on the knob, the program will be able to tell that there's a finger resting there. This would be useful because we would like to be able to know when it is a good time to move the slide potentiometers, and so that the program, the node program, would know that when a potentiometer move, is it being moved by the user or is it being moved by the system. Okay, and but the problem is the metal connector underneath this knob is fully covered by the plastic knob. So when I hooked up the touch sensor, it cannot even detect when my finger is resting. So I had to drill two small holes and then insert a wire or a cable, and the ends of these two cables are touching the metal base or the metal connector of this knob. So, and that in turn is connected to the pin, and the pin is connected to the capacitive sensor, touch sensor. So that gives me a really nice solid, reliable detection of touch. As I place my finger here, my finger is touching this wire, and because it's metal, it's conductive, and the touch get detected right away without any reliability issue. So that's nice. Yeah, just a little hack. Quick hack. Well, maybe there's a better way, a more elegant solution to this plastic barrier thing, but well, that's a problem for future day. And then the single board computer that I use is the PCduino. This is PCduino 3 from Linksprite. It's a powerful single board computer, dual core, integrated Wi-Fi, and it's just overall very nice single board computer. It has an onboard 3.5 mm audio jack, so pretty much any speaker would work. You just plug it in and you're set. And 5V 2 amps is not too uncommon to find a power plug for that. Yeah, it would run with 5V 1 amp, but not recommended because sometimes it would hang mysteriously, so it's best to stick with 5V 2 amp. Okay, the Raspberry Pi, initially the very early phase I was using Raspberry Pi, but Raspberry Pi doesn't seem to have enough processing power to generate a synthesized speech, especially when the sentence is long. It would stutter in the middle. So and then of course the single board computer here is also functioning as a web server, so that's additional processing load for the SBC. Okay, and then cables, one cable for the motor shield, one cable for the PCduino, and one cable for the USB hub. I'm using a USB hub and the Arduino, I'm just using the USB-B connection to the USB hub that ultimately comes down to the PC Arduino. Okay, and that's pretty much it hardware wise. Software wise, there's the Arduino code. Basically the Arduino code just detects user tactile input and then sends out messages via serial. And then there is a node.js program on the SBC that listens to incoming serial data from the Arduino and well, parses it and then basically picks up the appropriate line and then toss it out to a child process, generate eSpeak child process, and eSpeak generates the output all the way through the mic speaker, and so we hear the synthesized speech. And on top of that, the Node.js also serves the web interface, which is useful for text import and display of enlarged version of the text. In future, I might add more stuff to the web interface, like importing text via HTTP request, so another device can just make a HTTP post, attach the text message and send it to the Node.js program here, and then parse the text and make it available ready for the sliders. So right now there's only one option, to go to web interface and then manually click on import and then manually put in some text there, either by typing in or pasting text there and then click import. But in future there would be an HTTP post enabled. So okay, so that's planned for the future. I guess that's it for now. Thanks for watching.